Hi, we are going to make you go through the demo video of FI unit. We have Shubham Bora, who is project head for this unit. He will walk you through the demo. Please listen carefully and follow all the instructions. Shubham, you can please go ahead.
So this is the FI simulator for iSmart vehicles, which was manufactured by Hero.
Okay.
So this is the display unit
Okay.
from where we boot the vehicle.
Okay.
So with this ignition switch, all the displays get initialized and all the CAN communication also gets initialized at the same time.
All right.
So as you can see now, the displays are showing the readings obtained from various sensors and also positions of throttle body, position of the brake angle sensor, and also position of the idling air control valve.
Okay.
And this LED is for showing the fuel injected by the injector into the injector tank.
All right.
This is the ACG.
Okay.
So in actual vehicle the ACG rotates, but in this case we are not rotating it as it is mechanically not possible.
All right.
So we are simulating the pulses produced by the ACG in the actual vehicles.
Okay.
So these pulses are produced in the controller board that we have over here.
All right.
So this controller board is arranged as follows. The first three readings, the BAS, MAP and IIT,
Right.
these all sensors are inside the throttle body.
Okay.
Rest of the sensors and valves are controlled. TPS is controlled by the accelerator.
All right.
So as you can see, as I move the accelerator, the TPS
values
are
change.
changing.
Right.
ISCV is the idling air control valve.
Okay.
So it also changes according to the throttle position. That is
Okay.
the TPS values.
All right.
BAS is the brake angle sensor. This sensor is inside the ECU itself.
Okay.
So as you can see, if I move the if I tilt the ECU,
Right.
the values are changing.
Yes, they are
accordingly.
changing from
But
90.
the trick over here is that BAS don't provide the readings when the vehicle is actually moving.
Okay.
So it only provides trigger
Okay.
when the vehicle is actually moving. So you
Okay.
can't see the values changing with the ignition is given to the vehicle.
All right.
And there are few safety precautions to be considered
Okay.
over here. So this is an acrylic tank.
Right.
So make sure that you empty the tank when it is not in use. So
Okay.
make sure that the tank is filled with fuel only during the
Demonstration.
only during the demonstration, right?
So the tank should be always empty. And whenever you are using, then only you have to put the petrol. Otherwise, it has to be empty. All right, please go ahead.
And next precaution to be taken is that about the spark plugs.
Okay.
So we all know that the voltage here generated is around in kilovolts.
Right.
So make sure that you don't
Touch it.
Yeah, poke around it.
We have given the safety casing over there, but please do not put your fingers from inside.
Yeah.
Alright.
So now we will start the ignition, and you can see the spark plug generating sparks and
Okay.
the ignition injector
Right.
injecting fuel in the tank.
Right.
So you start the ignition by pressing the start button as
Okay.
you do in the normal vehicle. So now you can see this spark plug generating the spark, and the frequency of the spark generated and the frequency of the noise generated by
Right.
the injector changes as I move the TPS valve.
Okay. Yes, I can feel the change. I can see the RPM changing. I can see the TPS values changing. Right.
So currently the button position is on the output.
Okay.
So it is showing all the output from the sensors and the valves.
Right.
So when I press the ohm button,
Right.
so you can see the LED lit over the ohm button.
Correct.
And it shows the impedance of all the sensors.
Right.
So all the sensors have a particular impedance which changes according to the reading that they output to the CAN bus.
Fair enough.
So if I hold the EOT sensor for a while,
Right.
you can see that its resistance changes a bit.
Okay.
As
So
you can
from
see, there is a drop in the resistance.
correct.
So it is an NTC sensor, so it is a negative temperature coefficient.
Right.
So as the temperature increases, its resistance falls.
Fair enough.
So next is the output voltage produced by a few of the components inside the like in the bike.
Okay.
So TPS provides the output voltage as a percentage.
So this is we are in VO mode.
Yeah,
Yes.
VOM. So as I move the TPS, you can see the output voltage generated by the throttle position sensor.
Changes, yes.
Yeah. So it similarly changes for EOT, crankshaft position sensor,
Okay.
and also for the O2 sensor.
Okay.
O2 sensor we cannot demonstrate it because there's no combustion happening right now.
Fair enough.
And VI is the input voltage provided to all the sensors.
Okay.
So it is constant 5 volts. There is no tweaking around over it.
Right. So this is the demo, and how it is powered, this unit?
Yeah, this unit is powered by, currently it is using the internal battery that we have fitted inside it.
Okay.
But we can also use a 12 volts DC adapter.
Okay.
And
The adapter is provided with this?
Yes, the adapter, we have provided an adapter with it.
Okay. So this is the adapter hole.
Yeah. You provide power from there.
Okay. So it's normal 12 volt power.
Yeah, 12 volts adapter, and its power rating is 60 watts.
All right.
So make sure you can plug any 12 volts adapter, but its power rating should not be less than 60 watts.
All right.
It is recommended that you use the adapter that we have provided.
Okay. Anything else?
Yeah, if at any point you find that it is not powering up,
Right.
then just check the fuses in the fuse box.
Okay.
There's a possibility that fuse might blow up.
All right.
So just change the fuse and it will start working again.
All right. So thank you, Shubham. Thank you for your time. Guys, hope you will understand this. And if you have any queries, please let us know. Thank you so much.